My name is Jisong Ni.
And I am Ahmed Al-Said.
Our project is on a chart reading stock predictor. And my responsibility for this project is data collecting, image manipulation, data transformation into applicable input into neural network, and pre-trained neural network transfer learning.
And I'm responsible for implementing and training the new models we have.
So our data is 500 stocks from NASDAQ and the New York Exchange in the United States. We have over 40,000 data points in terms of minutes. The data is from April to August from 2017. So for the manipulation, we created 3 sets of data from these numbers. The first one is basically an original plot of the raw price. The second one is the raw price image run through a shift feature, highlighting the most important points of the plot. And the third set of data is a recurrence plot. Because this is a time series, a recurrence plot can show more features and patterns of the charts in different ways than the original raw price data.
The second topic we are covering from the course is neural networks. And for our first model, we have a modified ResNet, where we change the first layer into a coordinate convolution because our data is time dependent. So a change in the first pixels will be different than a change in the last pixels. The output of the network is one value that is activated by sigmoid that will tell us if the stock will go up or down. And we will be using this network to detect patterns in the data, and that will make the predictions. We hypothesize that it will make the predictions better. However, we ran into a problem of exploding gradients, and we tried to use weight decay and gradient clamping in order to better train the network. However, the results still did not come up as we wanted them, not as good as we needed them. So we created a new, simpler model, which is just a multi-layer perceptron, which achieved better results than the modified ResNet we have. And this is one of the biggest datasets that we have worked with. So we had to implement our own garbage collection for both the training and making the images in order to reduce memory usage. The results for the modified ResNet, you can see they are all the same for all the inputs. That's because the modified ResNet is predicting the same class for any input. So we believe that we are stuck on a local minima. Even after training it for 500 epochs, the results do not change much. For the multi-layer perceptron, you can see that we have achieved the best results on the plots augmented with shift key points. We achieved the 8% accuracy on the test set, and the worst was on the recurrence plot, which achieved only 57.8.
So we can compare our result with a pre-trained ResNet 18, and we can see that the pre-trained ResNet 18 actually does have better results on all of the data that we created. I think this is because the ResNet 18 did have a lot more images that it's trained from a lot more images than our own network. Also, this pre-trained model did not run into any gradient explosion problems, so it was predicting the 2 different classes normally. And this concludes our presentation.